A theory once believed to be the theory of everything, a theory that claimed the universe has 11 dimensions, a quantic power of Google universes, and even hint that our reality might be a hologram. How did something so breathtaking turn into one of the greatest embarrassment in modern physics? String theory, the myth, the marvel, the embarrassment. Right now, physics is stuck in a toxic love-hate relationship. On one side stands Einstein's general relativity, smooth, elegant, majestic. On the other, Schrödinger's quantum mechanics, wild, chaotic, unpredictable. Two masterpieces that refuse to work together, and stuck between them is gravity, a mysterious friend we known forever, yet understand almost nothing about it. We needed a bridge, we needed a hero, and string theory arrived like Moon Knight, brilliant, powerful, and completely broken. In the dawn of 1960s, scientists were desperately trying to understand the strong nuclear force, the glue holding protons together at the heart of every atom. Then something unexpected happened. A young physicist named Gabriel Veneziano wrote a mysterious formula that perfectly matched particle collision data. No one knew why it worked, but it worked. What nobody realized at that time was that this equation wasn't describing particles at all. It was secretly describing vibrating strings. And just like that, string theory was born. According to string theory, everything in the universe, electron, quarks, light, space and time, isn't made of point-like particles, but tiny vibrating one-dimensional strings. Change the vibration and you change the identity. Vibrate one way, you are an electron. Vibrate another, you are a photon. The universe becomes a cosmic symphony, one instrument playing infinite notes. And buried inside that symphony was a vibration that behaved exactly like a spin-2 graviton, the particle that carries gravity. Gravity wasn't added to the story. The theory predicted it. For a moment, it felt like physics had found the chosen one. But the universe never gives away miracles for free. To make the math work, string theory demanded something outrageous. Not 4 dimensions, but 10. 6 of them folded into beautiful complex geometric structure called Calabi manifolds. Shapes so alien and fabricated, they look like cosmic art sculptures. And what makes it more delusional, that the shapes of those dimensions determine the laws of physics themselves. Change the shape, change the universe. How many shapes are possible? You guess. 1, 10, 1,000, a million? Try 10 to the power 500 possible universes. Each with its laws, its own physics, maybe even its own version of you. Suddenly, prediction becomes not difficult but impossible. A theory that explains everything explains nothing. And the dream began to crack. Then came 1995, a turning point. At a conference in California, physicist Edward Witten walked on stage just like Tony Stark and dropped a conceptual nuke. Just like Moon Knight have multiple personalities, he revealed that the 5 different versions of string theory weren't rivals. They were actually different faces of deeper hidden theory, a theory not of strings, but of membranes, existing in 11 dimensions. He called it the M theory. What does the M stands for? Magic, mystery, metrics? Nobody really knows. But here's what shocked everyone. What we call a string might just be a shadow of higher dimensional membrane wrapped tightly around an extra dimension, and our entire universe might be stuck to a 3-dimensional brain floating inside an 11-dimensional bulk, like dust glued to a cosmic sheet. For a moment, hope was alive again. String theory failed where we expected it to succeed, but succeeded where no one expected it to. In 1966, Strominger and Waffa used string theory to count the microscopic quantum state inside a black hole, and their result matched Stephen Hawking's black hole entropy formula perfectly. Then came ADS-CFT correspondence, a duality suggesting that everything happened inside a universe with gravity is mathematically identical to a universe without gravity living on its boundary, which means everything inside the universe is written on its outer surface, which leads to humanity's most loved possibility. Reality itself might be a hologram. So yes, string theory is flawed. Yes, it may be broken, Yes, its prediction may be impossible to test, but it changed physics forever. And today, scientists are trying to revive it through something called the Swampland Program, an effort to cut away absurd infinities and bring string theory back to real-world prediction. Will it rise again, or was it the most beautiful scientific mistake we ever made? Only time and experiments will decide. My closing thoughts: the universe is playing music and we are still learning to hear it. Subscribe because the story of reality has only just begun.